Example 6. Listen closely. I like example 6. I'm not saying I like example 6. I like example 6. I like example 6. I like example 6. I like this because this is your first introduction. We're going to have to break a question into parts. Read along with me, Geo. It says a child slides down a playground slide, accelerating from rest. You know what? I would probably pause and I would underline the phrase from rest, and traveling 6 meters in 4.8 seconds. When they hit the ground, their legs bend 20 centimeters. First of all, I don't like centimeters. What units do we use for displacement in physics? So I might cross out that 20 and I might even do the conversion on the fly. I already said to you, it's probably worth knowing how to go from kilometers to meters. The other one that's probably worth knowing how to do in your head is how to go from centimeters to meters or meters to centimeters. 20 centimeters. How many meters? How many meters? How many centimeters in a meter? How many centimeters are on a meter stick? You've all held one, so I'm going to make the assumption that you've all at least seen the number. So to go from centimeters to meters is divide by 100. This is going to be 0.2 meters. And I might even like do it like that, lazy but organized. Cross out the incorrect one that I don't want to use. Still keep it so I can read it in case I need it later for some dumb reason, but then write the proper value above or below it. And then I would also underline rider stops. What does stops tell me? As the child stops, what does that tell me? Banner. What is VF as a number exactly? Okay. Banner, what's A asking me to find? Okay. And then B wants me to find the child's acceleration in stopping. You have not seen one like this yet, but I can tell right away that I'm going to need to divide this question into 2 parts, and I'll show you why in just a second. But what I'm going to do is I'm going to draw a line down the middle of my page. The way I know that is this 6 meters is a displacement, this 0.2 meters is a displacement. I have more than one displacement, I'm probably going to have to do this question in chunks. Or if I have more than one acceleration, I'm probably going to have to do this question in chunks. Or if I have more than one time, I'm probably going to have to do this question in chunks. It's trickier with velocities because we typically have 2 velocities, VI and VF. But I can tell you if you see 2 displacements, 2 times, or 2 accelerations, you won't go far wrong by breaking it up into halves, breaking your question into 2 parts. Then this next part, I know, Owen, because I've done a bunch of these. And as you practice, you'll also figure this out. I'm going to divide this into when we're on the slide and when we're on the ground. And I'm going to list all of my data and I'm going to try and put it either when we're on the slide column or when we're on the ground column. So from rest right here, where are we on the slide when we're from rest? On the slide or on the ground? So I'm going to say, you know what? On the slide, VI equals 0. I'll put that in the slide column. That's 6 meters. That's the next number that I see. Is that the distance that we travel on the slide, or is that the distance we travel once we're on the ground? So D equals 6. That 4.8, slide or ground? And it's seconds, so it's a time. Hey, I have 3 things on this side. I'm good to go. If I know 3 things, I can find the 4th. In fact, I can find all 5 things if I know 3 things. Keep reading. When they hit the ground, okay, I think the rest of this is going to be on the ground. Their legs bend 0.2 meters. So on the ground, I'm going to say D equals 0.2. And the child stops. I'm going to say VF equals 0. Now I'm going to read the question, part A. Christian, what does A want me to find? When it says how fast, is it asking me to find a time? What's it asking me to find? Starts with letter V. Initial or final, and on the slide or on the ground. I think even though it says on the ground, I only have two things on the ground column. I have three things here. Which velocity will be how fast I hit the ground? VF at the bottom of the slide. You follow that? So for part A, Christian, I'm going to write it here on the slide section, and I'm going to say VF equals question mark. Hey folks, I'm looking for an equation that's got a VF, a VI, a D, and a T in it. There is one. Christian, you can find the equation. Yeah. Yeah, it's the one with the bracket, the second one. Yeah. Okay. VI plus VF, close bracket, times T. You said it correctly. Now, you may be at a stage, and some of you will get to that stage today where you feel comfortable not writing this version out and going straight to the rewrite. In our notes today, we'll put this version in so that when you're studying, you know what the heck we did. And we're trying to find VF. Christian, what's that VF inside of? Starts with letter B. What's that VF inside of? It starts with letter B. We're going to do those last because it's reverse BEDMAS. So the D is going to drop down like a domino. Now what? Do outside the brackets. Ignore inside. What's that T doing to the bracket? So, yep. What's that 2 doing to the bracket? So, yep. We've taken care of that. Then the VI plus VF would drop down on the other side of the equal sign. How would I move the VI over? What's the VI doing to the VF? So, yep. Minus VI, and I'll put the VF equals over on this side. Now, Christian, in this case, VI is 0, and so it's not going to make a difference. But if it wasn't 0, that's where it would go. So it's going to be 2 times 6 divided by 4.8. I think I can do this in my head. 12 over 48 would be 0.25, so it's 1 decimal. Is it 2.5, I think? Units. Meters per second. Okay. Alrighty. Let's jump over one. Nate, what's B want me to find? What's B want me to find? Keep reading. I think we're on the ground. Okay, so I'm going to move over to the ground column. I'm going to say A equals question mark. Here's our problem. How many things do I know in the ground column? I need 3 to find the fourth. For a candy, can anybody see what I can use, what my workaround is? Marcus, impress me. Ah, VI, when I start to stop, must be VF at the bottom of the slide. The initial velocity that I hit the ground at was the final velocity at the bottom of the slide. I have to use this value and walk it over there. Well done. Let me get you your candy. I'm impressed. Most of the time I gotta give way more cues. You're way smarter than you. Or make that a problem. Get your kid. Now I know 3 things. I can find a fourth. I'm looking for an equation that's got a D, a VF, a VI, and an A in it. There is one. Shahab, which one? Yep. Squared, squared. Yes, VF squared. VI squared plus 2AD. Yep, you're right. VF squared equals VI squared plus 2AD. Again, you might have been able to skip writing that out, but we'll write it out. Ooh, what are we trying to get by itself? The A. So Nate, take us home. How do we get the A by itself? Oh, let's do that so we can see what we're staring at. What side is the A on? Right? So let's drop down like a domino. Go systematic. You don't need to go all at once. Yep. Minus what? Yep. Because it's reverse bedmass, so we do our dividing last. What are we going to divide by? That'll take care of that. What about this? So what am I going to divide by? That'll take care of that. What about this? What am I going to divide by? Help them out, folks. What are we going to divide by? 2D. Kept saying only one of them, not both of them. That's going to be A. Yeah.
Uh, I see problem. Like if we have is 0.
Yep.
So vi we have to square that, but if we minus vi, if we square that, we have a positive number again.
Let's see what you spotted something. Let's crunch the numbers and see if we can interpret how it shows up in the answer. I agree. It's going to be 0 squared minus 2.5 squared all over 2 times 0.2. Crunch that. What do you get? Hey, what'd you get? Pardon me? I don't think you typed it in correctly. You might have got your square. First one is this. Do you have the fraction button? So brackets around the top, brackets around the bottom. You're going to get something in the negative 15 range, I think. So I'll go negative 15.6. Before we discuss or interpret the answer, units, it's an acceleration. Yeah, I always do units right away so I don't forget because I have this idiot teacher who, is fussy about units. Oh, what's the negative telling me? When we hit the ground, what happened to our speed? Slow down. So I'm okay with that. Okay. Now, the other thing we could have done, and we haven't done much of, okay, which way is positive, which way is negative. We're going to get to that in the next couple lessons. We could have said down was negative and up was positive, in which case this 0.2 would have been negative. We would have got a positive answer saying you're accelerating up, and you are accelerating up. If you're moving down but you're slowing down, you're accelerating up. That I would take both answers here depending on how you set it up. Okay. What this is, yep.
Um, like I sorry, like when I calculate that
Yep.
I had, like I don't get in like his 2.5
Squared is positive, and then you'll have 0 minus something positive. The squared's not on that negative.
like
Yeah, yeah, yeah. It all works. The universe will take care of itself. We're good. Okay. This is just nerd trivia. Don't write this down, but look up. The other thing I like about this question is just this equation right here. This is one of the main equations that we use in reducing damage in car accidents. I don't know if you remember, I said what does damage is the acceleration. What does damage in any kind of collision? It's your acceleration. If you can reduce that, you're better. If we make this distance bigger, if we bend our knees more, what happens to the acceleration value? If you're dividing by a bigger number, what happens to this answer here? Gets smaller. You all figure this out when you're about 3 or 4 years old. It's part of what you figure out as a child when you're playing on playgrounds. You learn that when you land, you need to bend your knees. You may have seen, and sorry for those of you at YouTube, you can't see this. Watch a toddler when they're about 1.5 or 2. They've just learned how to walk. If they come to a small curb and jump off, they land all stiff-legged and they land back stiff, and you can kind of see it doesn't feel right to them. It kind of hurts. But by the time they're 4 years old, they've done enough running and jumping. They've learned now they land and they bend their knees. They've actually, it turns out, figured out this equation intuitively. If I increase the distance, the acceleration is easier. It's also why we build crumple zones in cars. If we can make the collision take place over a longer distance, we can reduce the acceleration. So there's some neat physics in that little equation right there, getting the A by itself. Owen's barely staying awake. I thought it was pretty profound. Anyways, that's okay. You were doing. You're back with me now? Yeah, you sure? Okay. I had given you all the homework from last day, so for the remainder of class, we're not going to be doing a lesson. Based on my last class, most kids finished off lessons 2 and 3 in class today and got a big chunk of lesson 4 done. Wednesday, shorter lesson, not as much homework. You'll probably have some time to work on lesson 4 and lesson 5. Wednesday, you're also going to get a take-home quiz on everything from lesson 3. The next class after that, also shorter lesson, we'll be doing actually a lab activity and just marking the take-home quiz. So I've thrown a lot of stuff at you because I've learned if I give you everything by the time we get to lesson 4, most kids now, if they go look at lessons 1, 2, and 3, they'll be going, oh, okay, I figured out how to do that just from the practice in the lessons. So let me hit pause on the video. Right click, pause.